any tool can talk to. So again, I could do ingestion with Spark, then run queries with Dremio. But if another team wants to run queries in the same data set with Snowflake, they can. That's the beauty of it. Because one of the big problems you had was everyone wanted to standardize to kind of simplify their world, but every team already had the tool that they liked. Some people, one team liked Trino, another team liked Dremio, another team liked Spark. Everyone had the tool that they liked, and everyone wanted to standardize on their tool. Okay. But if you have the data in an open format like Apache Iceberg, which is going to have the most robust ecosystem support, so that means the most tools available, they're going to give you the most amount of features for each tool, then every team can just kind of use the tool that they want. And then basically they don't have to fight over what tool to use because they can all use the same copy of the data with their preferred tool. And it can still be governed in a central way, managed and auditable in a central way, with giving people sort of the more sort of democratized tool choices. So that's the multi-engine piece. But how do you get there? Like like literally, like I'm in the process of writing 3 books. I originally wrote Apache Iceberg, the definitive guide. That's been released. Right now, I'm also writing Apache Polaris, the definitive guide. We'll talk more about that when we get the catalogs. But the 3rd book I'm writing for Manning is Architecting an Iceberg Lakehouse, which actually has large sections that are dedicated specifically to this migration piece on how you architect an Iceberg Lakehouse and how do you get there. And one of the tools, this is where I think a federation layer. So this would be a tool. I think Dremio fits this build pretty well, but there's also options like Trino. But some sort of federation layer where you can federate queries to multiple sources can really help the migration process. So at Dremio, we do this a lot for Iceberg Lakehouses specifically, and usually the process would look like this. Usually the first step is, because the idea is the challenge in migrating is always the change management. Okay, what happens when your users have to suddenly redo their workflows and rethink their workflows because you've moved all your data and you're switching tools and things like this? How do I make that pain less? So we'll use an example of someone who's maybe using currently an S3 Lakehouse. It has a S3, well, let's say they have a Snowflake data warehouse, and they also have a Postgres database. And right now they ETL most of the data into eventually into Snowflake, but there's a few data sets they don't bother, and they're still in Postgres. What they can do is then the first step would be to connect both of those to, let's say, a federation layer like Dremio. So now I can actually see all those data sets in one place, and then you build out your semantic layer. And the semantic layer is usually going to be like a bronze, silver, gold. So your raw layer would be your select star views. So it would be like select star on snowflake.sales, select star on snowflake.orders. And then same thing for like the Postgres data sets. And then what you do is you'd model your silver and gold layers there in the Dremio semantic layer. So now what you have is everyone's existing workflows, their existing dashboards, their existing AI and ML workloads can all work off that semantic layer with everything nice and defined. So going forward, the end user, the consumer, does not have to care about where the data is stored. Like they're just going to connect to the gold layer that they're used to connecting to. And, hey, here's June sales. They're not going to think about it more than that. Now going forward, then behind the scenes, what you can start doing is then you connect your Iceberg catalog. So you can either deploy your own Iceberg catalog. Dremio does have an integrated one, so you don't even have to set one up yourself. You can just deploy Dremio and it's there. But you could also use one of many different open source catalogs like Apache Polaris, Gravitino, Lakekeeper. There's a bunch of options. But you connect whatever catalog that is to Dremio, and then you begin designing your ingestion pipelines, which could again use Spark, could use Confluent, could use Flink. There's a variety of options on how to get the data into Iceberg. So let's say, and you can do it one step at a time. Like you don't have to. That's the beauty of using a federation layer, is because you don't have to move all your data to Iceberg one day or the next. This is where people hit a lot of walls, because the way they do it is they're trying to shift from one paradigm to another overnight, and it becomes really hard. So this way I could choose one data set. Like I can think, hey, which data set's costing me the most right now with my current paradigm? And then maybe move that data set first. So maybe I move sales over to Iceberg. So now all I have to do, once I actually have all my pipelines set up and I know that the Iceberg version of the sales data set's nice and in sync and has the current data and it's good, everything's been tested, then all I have to do is go to my raw layer and my semantic layer and just update the view to say, instead of select star from snowflake.sales, select star from iceberg.sales. And now going forward, all the rest of my semantic layer, all those views that I created on top of it are automatically going to adjust. And that'll the nice thing about that is that once those data sets are in Iceberg, they stay fast, because let's assume that you use like the Dremio catalog. Dremio will automatically optimize those tables for you. And then Dremio will automatically accelerate queries based on those Iceberg tables for you. So what's going to happen is that their day to day, you're just going to keep seeing your query performance improve because Dremio is going to be managing all that behind the scenes. But you can still bring it whenever you still need those Postgres data sets. You can still join them in your semantic layer, and then eventually what you do is you've now migrated all your data sets and you're just now natively on Iceberg and without as little impact as possible to your end consumer during the transition.
Yeah, I have a question. Maybe this is my ignorance, just not knowing the world, but also a good place to ask this question. How do you deal with multi-regional data that's homogeneous, right? So let's say you are processing sales transactions from Europe, US, and Japan, and then these transactions have a similar structure, but moving data across regions is expensive, right? So, and also you might want to have processing done for some purposes here and some there. How do you manage this? How do you do it in order to avoid this, or do you even try to avoid this?
Oh, of course,
cross-continent traffic.
Yeah. So there's a couple different ways you can handle it. I'm going to speak to it from what I know. So being here at Dremio, I've seen how we solve this problem. So I'll speak to that. But in the sense that you can deploy multiple Dremio, the Dremio can be deployed either as a SaaS or it can be deployed self-managed. So what we do is especially with like a lot of our European customers, we'll see that they will deploy multiple deployments of Dremio in different regions or in different places based on sort of data locality rules and whatnot. So then what will happen is that they'll create views that do the processing that needs to happen in that region will exist within sort of that instance of Dremio, but then those Dremios can connect to each other and they can share views with each other. So then what happens is just like the view, basically, once the data gets processed to a certain point, that view is shared with another Dremio instance, and then it can then join it with other data sets and do the additional processing from there. So after like PII has been maybe moved out or certain transformations have occurred. On top of that, now to minimize the egress, Dremio has a feature called reflection. So that's sort of the acceleration feature. Now that can work in two different ways. And first, let me just define what reflections are, because this is what it's probably like the most unique and really cool feature that Dremio offers. And it shows one of the ways that we kind of really embrace Iceberg early on. Like, as far as like commercial companies selling, like thinking of Iceberg as a product, we were probably the first who really kind of embraced Iceberg. And we kind of did it in phases. Okay, so originally when we were like a data lake engine, and sort of the first iteration of how we use Iceberg is, instead of exposing Iceberg to the end user, is we would allow a user to take a folder of CSV files and say, hey, I want this folder of CSV files to be a table, or this folder of Parquet files. And Dremio under the hood would generate Iceberg metadata around that folder of files. And basically the Iceberg piece was just kind of abstracted away, and that allowed us to scan that folder really, really fast. And we were like we still are the fastest data lake engine, but that was the secret sauce. But then the thing is that people wanted, ways to accelerate tables. Usually people would do it like materialized views. And the problem with materialized views is that, one, you have to maintain them. So you have to figure out when am I going to refresh this materialized view, how often. Two, you create a whole other namespace. So if a data analyst complains to me and say, hey, my dashboard's slow, I create a materialized view, they got to know what's the new name of the new thing, and they got to go update their dashboard to point to the new thing. So now there's a step that's out of my control. They got to go update the thing. And then three, it's always like a full copy of the view. Maybe I don't need a full copy of the view. Maybe I only need a couple columns. Then what happens? And then I have to create another view with just those columns and then materialize that. That's like just two extra steps. So what Dremio created was reflections. It's kind of like the concept of materialized view, where you're creating a materialization, but there's one really cool benefit is that they're Iceberg tables. So what it does, it actually manifests that materialization as an Iceberg table in your data lake. So it's kind of like you have the physically better data structure in the sense of the Parquet files, and then two, you have the essentially like an index is the metadata for the Iceberg tables. So it's a much faster thing to scan. But two, you can actually like tailor it. So if you're talking about like a BI dashboard, I could do what's called an aggregate reflection that only materializes the sums, kind of like a cube. Or I could do a raw reflection, and let's say the queries I expect are only a few columns. I can say, hey, only materialize these columns. But I don't have to create another name. So the existing dashboard that's already pointing to the original like view or table, it's automatic. Dremio will automatically detect that this reflection exists and swap it out. So the end user doesn't have to do anything. You don't have to create like all these different namespaces that you have to juggle and say, okay, hey, for these queries, query this. For these queries, query that. Dremio will just know, hey, swap this out for this query, swap out this query based on the query patterns. making it much easier for the end user and much easier for the engineer to kind of decide what they want to do. So
do I understand correctly that sort of in the materialized view, you have kind of a reference to a row table, so part materialized view, part real view, or am I misunderstanding?
Yeah, so generally the way it would work is on Dremio, when you're taking a look at it, you have your raw sources, which are generally going to be your raw layer, and then everything else is, you generally model everything as views on top of that. And then what you do is when you want a particular view when you want to materialize something, that's when you would turn on reflections, and it would create these materializations, but they don't show up in your model because Dremio will transparently substitute them, and they're all Iceberg based. So that's how they speed things up. Now, so for your existing data, that's, you would have to turn these on manually, and there's still certain things you have to think through manually, like how often should this reflection update and things like that. Now, once your data is natively in Iceberg, Dremio can now autonomously manage this. So there's a couple, basically this reflections feature gets upgraded. So for Iceberg tables, the updates of these reflections are done when the data changes, because it can detect the snapshot update. 2, it does it incrementally, because it can figure out, hey, what's the difference between snapshot A and snapshot B, and only update the reflection based on that. And then 3, it can automatically determine when to create and delete these reflections based on your query patterns each day. So then this becomes something you don't even have to think about or notice. But the reason I bring this up is going back to the egress fees. What people will do is that once they model that multi-regional data, they'll turn on a reflection, so that way there's a materialization of the result that's local to reduce the egress fees that are happening. So that way that multi-regional computation will only occur when needed, depending on sort of what your SLAs are and things like that.
Cool.
But you still need to set the freshness, right? Like how would you?
It depends on the data set. So if it's not an Iceberg table, you do need to think about when you refresh the reflection, and there's a bunch of things to think of there. So you can set that. What a lot of people end up doing is that there isn't a REST API endpoint for Dremio to trigger that. So people will just build that into their pipeline. So they'll say, hey, whenever this thing ingests, it's going to hit the REST API, and that just triggers Dremio to go update that reflection, and then Dremio handles it from there. But if it's Iceberg tables, then Dremio handles it all, because then Dremio can detect everything and basically becomes zero work at that point. So
maybe we'll move back to Iceberg a little bit.
Yeah.
So you've mentioned data catalogs as one of the primary components, right? So what approaches are there building catalogs? And I've read about Dremio's 𝗪𝗍, right? And then that's first of all, it is open source, if I remember correctly.
Yep.
And it uses this Git style branching to manage your state, I guess. So maybe you could give us a little bit of context on what other approaches are there and how do they compare?
Yeah. So first, like the concept of an Iceberg catalog, like at the end of the day with the Lakehouse catalog, what it's really doing is just tracking 2 things: the name of the table and the location of the table. Okay, so saying, hey, table A is here in your data lake. Now, the difference between like the way like you would catalog a 𝗬DC or a Delta table, because the way 𝗬DC and Delta tables, usually the location would just be a folder, because they're very locked into all the files being sort of within a particular folder. Iceberg, on the other hand, isn't locked into that. One of the unique features of Iceberg is that files can literally be anywhere, which allows you to experiment with the way you lay out your files for reasons of like optimizing for different object storages, because certain object storages, if you have too many files in one folder or one prefix, you can get throttled. So Iceberg created a sort of a decoupling of, hey, all the files have to be here in order for you to be able to understand where the files should be. So with Iceberg, instead of saying, hey, this folder is the table, because we don't know if all the files are in that folder, instead you have a metadata file that acts at the top of the metadata tree. So in Iceberg catalogs, it's, hey, the sales table, and then here's the S3 address for that metadata file. So whenever you think about Iceberg catalogs, that's all they're doing. And any Lakehouse catalog, all they're doing is saying name, location. For 𝗬DC and Delta, it's usually a folder location. For Iceberg, it's usually the absolute address of a specific metadata file. But either way, once an engine knows that, it can then discover the table. There are a lot of catalogs now. This has become sort of the new sort of gold rush in the Lakehouse space, because the idea is oftentimes wherever you catalog your table is also going to be sort of where you get a lot of other table services, which is sort of like the final piece, like the optimizing of your tables, the cleaning up of your snapshots. And so basically the idea is from a business standpoint, okay, when you think of like just sort of data vendors, what do they want to do? They want to run as many of your workloads as possible. So there's the end of, hey, I want to run your actual analytics workloads, your ingestion workloads, but then the third category is your maintenance workloads. Okay, and generally whoever your catalog vendor is oftentimes going to be also your maintenance vendor. So just to think sort of like they're not set, so you don't pay for the catalog, you oftentimes pay for the compute with managing your Lakehouse by having that catalog.
And this management is critical, right? Because the metadata can grow very quickly, and
correct.
It's easy to without maintenance, it's easy for it to outgrow the actual data that's there, I guess.
100%. Basically, what happens is that you start accumulating a lot of files, and this is not a database, not a data warehouse. Database and data warehouse, they just do this automatically under the hood because you have some sort of software that's just running 24/7. The whole beauty of Iceberg and Lakehouses in general is you don't have to have something running 24/7, but you do need to have something running here and there to run these kind of optimizations. So that's become sort of like the new place a lot of vendors are kind of building out their Lakehouse services. Like originally, the first like layer, the last couple of years was just vendors building out their read and write support. Now that's kind of, not everyone generally can read and write most table formats, definitely Iceberg. I think that's the only one that's like truly like, I can't think of anything that doesn't support Iceberg. And then now you're starting to see more maintenance stuff, especially for Iceberg.
I've read about two interesting projects because again, I'm just exploring this, but I've read about the Rising Wave team releasing NIM tables, which is a maintenance tool, and already existing Apache project called 𝗓𝗏𝗄, which also is an open source maintenance tool. So if you would like to build this on scratch on bare metal, you can. And probably others exist as well. It's just that I don't know the many.
And Spark built into the Iceberg libraries. So what a lot of people did up till now is they would just automate different Spark pipelines to go do a lot of this optimization. Now, as far as like, and then in the vendor specific space, you have like Dremio catalog, you have Snowflake with their different Iceberg catalogs. They have two different Iceberg catalogs, Horizon and Open Catalog. And the cool thing is that Dremio catalog and Snowflake's Open Catalog are both based on the same open source project, Apache Polaris. Because Apache Polaris was actually something that we co-created with Snowflake. When Snowflake announced Polaris, and that initial version and pretty much everything up till now has been a joint effort between Dremio and Snowflake building Apache Polaris. It's actually a lot of the same developers you saw from 𝗬cie came to work on that project, because basically Dremio, we brought a lot of experience building open source catalogs. So we were approached to help on that, since we know how to navigate the open source space and have been in that space. So we've been very strong partners on the Apache Polaris project. But yeah, so we did create 𝗬cie. 𝗬cie does use versioning of the catalog. Probably the biggest deployment of 𝗬cie that I know of is another company called 𝗬𝗏𝗏 that basically builds sort of like serverless Python runtime. So that way you could literally just run Python scripts that do Iceberg workloads and just run them against and then under the hood, they're using 𝗬cie to kind of version your pipelines. So that way you can do repeatability of that. That's probably the biggest usage of 𝗬cie at the moment. It was also popular with financial companies who do like a lot of stress testing, so that way they can version their data. So because they have to literally basically modify that data and then toss out that modification every day to run these stress tests. So they would just create a branch, kind of like a Git branch, modify the data, run their stress tests, and then when they were done, they could just drop the branch, and then they were done. They didn't have to touch their production data. They didn't have to make a complete copy of their data. That worked out really nicely for them. But
Sachin, I actually have a question for you on this topic, because we've talked about this a little bit, and you've written about this, I think, as well. Ducklake. So how does this play into this whole space, right? They do the catalog problem a bit differently.
Yeah. So essentially,
sorry. This question was actually for Sachin. I hope to get your comment as well on this, but Sachin, if you maybe could start on this.
Yep. So Ducklake is pretty interesting when we were talking about, like, as Alex recently mentioned, on managing. Most of the companies are trying to control the catalog, right? Now Ducklake just came with this: don't store your metadata into your file storage, like object storage. Instead of that, store it into your databases which support SQL. Right now, they are saying that with this storing those things, like all your so there are like three ways of decoupling. One is you're decoupling your metadata. So earlier there was two-way decoupling, where we had decoupling of your data and compute, storage and compute. Now we have a decoupling at metadata layer as well, where you store your metadata at your SQL-based, maybe your Postgres service or whatever, right? So now what they are saying is, with this petabyte of scale of data, you can have huge concurrency, which Iceberg cannot tolerate. That's one point. The other point is that they are saying is, with petabyte of data, you can do query planning and metadata scanning, all those things within 2 milliseconds, which the cold S3 would take maybe 100 of milliseconds. So this is from their podcast. This is from their blog and documentations. We'll definitely love what Alex thinks on this and what his thoughts.
Yeah, I mean, I appreciate the fundamental idea of saying, "Hey, what if we stored the metadata in a database?" I do think sometimes like they oversell the idea a little bit. Like, because the thing is that it's not something you can't do in Iceberg. Iceberg has something called the Iceberg REST catalog. Essentially, it's a uniform interface for dealing with Iceberg catalog. Now, essentially, this abstracts away the whole metadata fetching in Iceberg. So someone could create a catalog, and most catalogs do a level of metadata caching into a database that's actually doing this already. And then like a lot of the concurrency stuff is really going to be less related to a lot of these factors, more to how the engine runs the query. Okay, so like for example, like an engine, and again, just speaking because this is what I know Dremio can handle pretty much those kind of scales, because Dremio, along with accessing the Iceberg, does a lot of caching along the way, and also is able to scale out its engines to hit those scales. So in that case, like we have customers doing stuff like that with Iceberg, so it is possible. And then also, it's again, as far as the fundamental design change of, hey, let's store the metadata in the database. That's something you could do with Iceberg. They could have just as easily created another Iceberg catalog that just took this fundamental design philosophy. The problem is they've created a whole new format, which means there's a very limited, like theoretically, yeah, great, it's faster, but no engine supports it. Like basically, you can use DuckDB and maybe Spark, but now pretty much every other tool, and then it's already a tall ask. Like you've already seen this this is the reason why why standards matter, because again, this is why you had like the whole Iceberg Delta Lake conversation the last couple of years, because every vendor can't build support for everything, especially when you think about when you're talking about table formats. It's literally like building a separate database for each one, because there's all these different features you got to build out. So there's got to be sort of one that everyone kind of agrees on. And
I think that the Iceberg won with data tables, because I think that by now we can say that it won in a way that it had a wide ecosystem support, right? That data tables was open source, but this was developed primarily by Databricks, and probably it's a great format, but because Iceberg was so distributed, everybody.
And there's a reason for that. Like I mean, like Delta is a great format, but like it's designed in order to get the maximum value out of Delta Lake, you do really kind of have to be a Databricks customer. A lot of the features, the best aspects of it are part of the project, but it's fundamentally, when you want to build an ecosystem, every vendor has to ask the question, sort of like, what are my risks? So when you build on Delta Lake, the risk is, hey, what happens if Databricks makes some breaking change tomorrow? I mean, sure, it's an open source project, but when it comes to the fundamental, like the Java API, which is the key where all the major changes happen first, that is still heavily geared or steered by Databricks as a company. Yes, it's open source. Yes, it's a Linux Foundation project, but it's still primarily steered by Databricks. So that means as a vendor who provides services for a Delta Lake table, there's always the risk that, hey, tomorrow they change the API enough that basically, hey, they've just broke your support, and now you have a bunch of angry customers. Versus like a community-oriented format like Iceberg, where you have lots of companies arguing all the time. If you ever listen to the Iceberg list, not arguing, everyone's pretty nice, but debating what the new feature should be. Usually, yes, it takes a lot longer for a change to happen, but everyone knows the change is going to happen. Like they just approved V3 of Iceberg. Everyone knows it's going to happen. It's going to be like maybe 6 months before everyone builds a functionality, but everyone knows what that functionality is going to look like. Everyone knows what they're building towards. Like the whole, what features you're getting, and it can happen across the entire ecosystem of tools in a way that doesn't, no one feels like, hey, they're taking a huge risk that someone can pull the rug out from under them.
Yeah. So what features are we getting in Iceberg v3? What's the difference? What problems are being solved?
Ian, before just a second, sorry, before we go there, I have a couple of questions on catalog, so that let's close the catalog and then maybe move. I really have a lot of things at V3 as well, but like at catalog, what do you think? So like Databricks announced full Iceberg support, Snowflake allowed full Iceberg table support, right? And with V3 and Tableau acquisition at Databricks, right? And with V3 article getting released specifically by Databricks as a standard, right? So, what are your views on this catalog war, which initially started and now where it is converging? And what do you think about the future of Iceberg and Delta Lake as an two major players in this field?
Yeah, I mean, Delta Lake is always going to have a place. At the end of the day, like Databricks is still always going to innovate in Delta Lake because they can iterate faster. Like that, it makes sense for Databricks to want to continue building on Delta Lake because they can change the Delta Lake format faster because they don't have to ask permission, and then that means, and then they can build services around that Delta Lake. So that to the extent that people use Delta Lake, they'll always have this advantage that they're going to want to keep. But the fact that they've built support for Iceberg is a recognition that, hey, there is going to be this broader industry usage of Iceberg that they don't want to necessarily be locked out of. So at the end of the day, like as Iceberg as a standard, yes, but just because there's a standard doesn't mean isn't going to be other things. There's going to be a place for Delta Lake, a place for 𝗬𝗽𝗲. There's going to be a place for 𝗬𝗲𝗄, a place for Ducklake. I don't think that these things are not necessarily going to exist, but when I think of what are most vendors going to build on, it is probably going to be Iceberg, and that's pretty much been proven out over the last few years. And as far as like people always say, well, are they going to merge? They can't really merge. Now, what they are doing, which I think is great, is the communities of both projects have been working together more on the primitives that make sense. So this, in a sense, some of the things that are coming in V3 are the variant form data type and the geospatial data type. But the thing is that both of these formats, for the most part, the tables are built on Parquet tables, or Parquet files. And the problem is you can only support data types that can be stored in those Parquet files. So both formats and 𝗬𝗽𝗲 and 𝗬𝗲𝗄 benefit to work together on helping expand the data type coverage of Parquet files. And they both benefit from that. So there's been cooperation in the communities against those things. And now, and also when one format has a good idea, it's great if another format picks up on that. So in this case, the evolution of how merge on read was done. So I'll tell you the long story just to kind of get the full evolution. But essentially, the first format to really do merge on read, the ability to do sort of these quicker updates, was 𝗬𝗽𝗲. 𝗬𝗽𝗲 did it first. But the way they did it is that a table is either merge on read or copy and write, which is fine. But what they would do is they would create these log files. So you would have the original data file, and then every change is this additional log file, which would create a lot of files to manage. Iceberg did it a little bit differently. Iceberg was the second one to do it. And then what they did is they said, okay, you can have copy on write or merge on read, but instead of storing all the changes per file, we're going to create these different types of delete files. And there was two types, equality deletes and position deletes. And they worked. Like they definitely allowed you to do quicker updates. And then the third version, so the last one to kind of get in on this was Delta Lake, and they came out with a feature called deletion vectors, where instead of having all these multiple files, you have one sort of binary representation of all these updates. Okay, and always, if you come in later, you can come up with a better version because you learn from the mistakes of the past. And that wasn't sort of a good version of solving that problem. So with the communities working together, they brought that idea over to Iceberg, and now you have deletion vectors in Iceberg starting with V3. So now instead of storing it in these delete files, with V3 tables, they'll store it in what's called a Puffin file, which is a standard that came out of Iceberg for storing additional binary information. You can store, hey, these are all the files, all the records that were deleted in certain files in one place, so you're not iterating through as many files and whatnot. So in that case, that's great things. Now, does that mean that the two formats are the same? No, they're still fundamentally very, very different in their architecture. And they'll never merge in a sense, if for one fundamental reason is Databricks is never going to want to lose the advantage of having the influence they have over Delta Lake. And an Apache project can never be something that is controlled by one vendor. So Iceberg is always going to have this level of democratization if it's going to maintain being part of the Apache portfolio. So there are always going to be two projects. Where there's good ideas between the two, I'm glad that they share them, and I'm glad the two communities are working together. But when I hear like the FUD about like, oh, they're merging, oh, they're the same, I'm like, it makes me cringe a little bit. And then circling back a little bit to the catalog wars and where I think that's going, I do think in the same way that Apache Iceberg eventually beat out Delta Lake, I do think Apache Polaris will eventually beat out Unity. In the same way, Delta had more features than Iceberg ahead of time. So if you just said, hey, based on like the features that they had, you would have thought, oh, Delta Lake's definitely going to win. But the problem is, at the end of the day, people are going to want ecosystem support. And you're already seeing the ecosystem support. Yeah. And then Apache is always the safe way to go, because you know that you have this foundation that really strictly enforces these rules about making sure that it's a community project. Okay, like I know some of the Apache board members, and they are strict. Like they will get on you if they smell any impropriety as far as like people trying to take commercial control of a project. And Apache Polaris is already getting huge sort of support. Like, I mean, right off the bat, you have Dremio and Snowflake. Snowflake has open catalog, their managed version of Polaris. Dremio catalog is a managed version of Polaris. I know a few other companies that are there, at least 2 or 3 that are coming out with managed Polaris. I do assume that pretty much all the data catalog companies are going to basically build a managed version of Polaris into their products. I wouldn't be surprised if the clouds end up doing a managed version of Polaris into their cloud products. Like if I were Microsoft, this would be like the easiest way to expand their Iceberg support. Because basically they have a little catching up to do there. But
just
I know
another service we can host.
yeah. But the idea is that anyone can build a business on that, and then everyone can work together on the feature of that. And so right now you have that core strong Iceberg support, but it's already growing to be beyond Iceberg. They just added a feature called generic tables that's going to allow it to support other table formats. Now, the thing is that once you start getting beyond the Iceberg REST spec, the Iceberg REST catalog spec, it does become a little bit more tricky to make sure you have wide ecosystem support. So for those kind of features to really win, Apache Polaris, and the same thing for Unity catalog and its federation features, it needs to become the standard. Problem is, like, Unity catalog will never become a product of anyone else but Databricks. So
also surprisingly they are releasing, so this full Iceberg support is for their managed tables, which are managed by Databricks, and same for the Snowflake. So it's again a lock in there. I think we also have no, go ahead, you have some points.
Oh no, I was gonna say 100%. That's why, like, and then I think like using something like Snowflake Open Catalog, which is like the open version, which is based on Polaris, to me generally would be the better route to go, because you do want to use the open. You always want to try to stick to the open, so that way you have that migratability. That's why, like in Dremio, we always build on the open alternative. We don't have like our locked-in version and then our open version. It's always the open version. Yeah, go for it.
Yeah, so we also have a question, but that also clubs to the question that we also had. There are a lot of CDC use cases or row level changes that people want to materialize this into their Lakehouse and then do analytics based on their primary keys and things like that, right? Given that Iceberg and Delta don't support a native primary key, whereas like 𝗏𝗏 at 𝗙 natively supports, right? What are the ways you think first we should handle these type of load, right? And this, like, efficiently handle this type as compared to 𝗏𝗏 and 𝗙 for CDC streaming loads? And what should be the ingestion pattern? Like, what should be the tool that we should be using for ingestion in that regard? So, like, 2 aspects. One is on the ingestion part. The other one is on the storage part, like solving the small file size problems and stuff like that.
Got it. Okay. So I guess I'll talk to you a little bit what was unique about 𝗙 and 𝗏𝗏 first, just to kind of put context. That the way I would think about it is that the two 𝗏𝗏 and 𝗙 were more focused on solving ingestion problems, while Delta and Iceberg were more focused on solving read problems. So in that regard, yes, I see like 𝗏𝗏 has a lot of different innovations on trying to really, and that's why like they specialize in sort of really low latency streaming ingestion. And oftentimes, like if that is like a must, ingestion into 𝗏𝗏 is oftentimes where people go. They'll use a service like OneHouse, and OneHouse will you use a 𝗏𝗏 based ingestion and then use Xtable to translate it to Iceberg or Delta for consumption. Now as far as like Iceberg and Delta, them having like primary keys, I mean, I assume it'll eventually happen. It's just like, again, I think their roadmaps and the communities have always been more consumption focused and making it a more focusing on the read optimization versus write optimization. But my assumption would be, at least for Iceberg, that eventually it becomes an index that you find in your Puffin files. That would, to me, be the most logical place to put it, because you can store it as binary. It'll be most condensed. You're not reading another file. You're just, basically, honestly, I think most new types of metadata indexes, anything, will probably just be more Puffin blobs going forward. Just that way, hey, you just open this one Puffin file, you iterate through the blobs, you use the blobs you need, and then that's just seems to be just a much more efficient pattern. I mean, again, there comes a point where, hey, what happens when you have too many blobs in there? Or the file becomes too big because it's storing so many blobs. But I'm sure we'll cross that bridge. So that would be my assumption there. I do think also, I think semantic layer tools will be a good place for handling some of that. But again, that's more on the consumption side. Now, as far as like what tools to ingest, I don't have a particular opinion there, because it really depends on your ingestion patterns. And it also depends on sort of like who you have doing it, like in the sense that, like, are there going to be someone who's comfortable like managing a Flink deployment and writing Flink code and doing everything in Flink? Like, oftentimes you're going to get the most flexibility using a tool, like Flink self-managed, but it also requires a lot more work on the top of in the part of your team, versus using something like Confluent, which is going to be manages a lot of the more complexities for you. You're still using Flink and Kafka under the hood, but it makes it a lot easier. Or using things like Red Panda, Rising Wave or whatnot, all these other streaming tools. I do think Iceberg streaming ingestion is going to be a sort of a big area that's being solved. In the sense, like, you can stream the Iceberg, like trying to figure out what's like who can do it the best. I think is currently a big part of what's going on in the market right now. That and catalogs would be the sort of like the two places, to me, I find like what's going on in Iceberg interesting.
Do you find, talking to different people building these things across the world, do you find a lot of interest in low latency or real-time data pipelines? Because the analytical world traditionally, it's always been batch, right? And not that long ago, these capabilities to build rather simple real-time pipelines have emerged. But when talking about this with different people, especially in the analytics world, I very often got the question, why would we care, right? Our stakeholders need a daily report or something like this. And so the question to you is, do you see an interest? Have you seen this need? Is this there at all? Or?
Oh, for sure. I know there's a lot of people. I mean, I would say oftentimes it's going to be like financial companies where like real-time data really kind of makes a big difference. But I mean, I think a lot of times people focus a lot on trying to get to land the data real time, and then realize, wait, can I actually run analytics on it real time? That becomes a bigger challenge. There's ways to do that. Like, you can build things like, and then just run the analytics in midstream through Flink, depending on what your use case is. Like, if I'm just trying to look at, hey, the last 5 minutes, I have a dashboard that shows me the last 5 minutes of prices. I can always just say, hey, let me go hit the stream, query the last 5 minutes worth of events with Flink, and then deliver that to like a dashboard or something. But again, how often do you need? Certain people need that. I would say probably most people don't. I do think a lot of people are trying to build that don't need it. This is why, like, in the book that I'm writing, Architecting Iceberg Lakehouse, there's a whole chapter just dedicated to asking these questions, like figuring out, okay, who are the people who are going to use this Lakehouse? What do they actually need? Figuring out what their SLA is, what were the challenges they've had before, and kind of doing that kind of audit before you just jumping on the thing. Like,
I saw in a lot of Confluence communication, the theme that seems obvious is that low latency data is always better than high latency, because the value of data diminishes over time, right? Mm-hmm. And while I do agree, the question is how much it diminishes, and who actually needs this. Let's say we have a dashboard showing the consumption of our gas stations, whatever. And like, do we really need a second latency, or maybe the dashboard can have 15 minutes latency? How much does it cost, right? Because low latency always costs more than high latency. This is something that needs to be optimized for. And so I guess our world is still exploring which use cases really need it, and how much they are going to pay for it.
Another thing I've seen mentioned a few times is like, oh, they want to ingest the data faster, for like AI ML use cases. But I'm like, okay, well, if you're training your data as it's coming in that frequently, that's going to get really expensive really quick. Like, again, a lot of people realize, hey, I want to get the data fast. But again, just because you can get the data fast doesn't necessarily mean you can consume it fast. And I think, like you're saying, like that's really the thing that people need to introspectively like think about and look at. I say for most use cases, I would still lean towards batch for most things, or even micro batch, depending on the specific use case. Like again, there is a point where like micro batching becomes more expensive than just streaming it. So like,
yeah.
You figure out where you, but yeah, it requires everyone to kind of, but people need to ask those questions. That's if anything, to anyone listening, that's the takeaway. Don't just assume. Run your tests, ask the questions, talk to people, take a look at what's actually going on in your data infrastructure and the actual queries you're running and the actual insights that you're getting before you jump on any direction.
Yeah.
Talking about how real-time are the requirements are, like these bigger warehouses or data systems like Databricks and Snowflake have integrated a SQL or PostgreSQL compliant databases such as Lakebase in Databricks, and Snowflake also is coming up with something similar. What do you think? Like, what's the most interesting use cases that you have came around, or you think that where we are going with that?
Yeah, I mean, I think it's just at the end of the day, like, there's only so much analytic workloads you can capture. So if you can start trying to capture operational workloads, that's one way to grow when you feel like you can't grow when you need to find new ways to grow. I don't think it's necessarily anything too new, because I mean, we've seen, you have Aurora on AWS, and that has integrations with Redshift. So I do think it makes sense that once you're a platform that's grown to a certain size, then you have to expand to similar categories. So, okay, hey, the expansion of Snowflake and Databricks, considering their size, to get into more operational spaces makes sense. Like how transformational or how like big a deal this is, I'm still very skeptical. Like it's Postgres. I get it, serverless Postgres, but like serverless Postgres isn't necessarily new. But I get it. Like, oh yeah, well, if you use our serverless Postgres, it's going to integrate better with our stores and all our analytical stuff. So let us just do everything for you, which is always what everybody wants, right? Everyone wants their customer to do everything with them. But again, my skepticism always is on the lock-in side, which is, like why I love working at, because like in Dremio, we design everything in the sense where basically you use the pieces you want, and then you can use Dremio where you want and not use it where you don't want. We don't really like say, hey, you have to use Dremio for everything, or try to get you to use. There's a lot of things it's a much more sort of like a different approach to things. But I think it's cool. I mean, to me it saddened me, because when I was a web development bootcamp teacher, I used to always use like bit.io as my free Postgres thing for my book cohorts, and then Databricks bought them, and then I started using Neon to teach Postgres, and then Databricks bought them. So if I were still a bootcamp instructor, I'd be like, okay, where am I going to use free Postgres now?
Databricks, of course.
Yeah.
It's nice to hear a bit more reserved opinion, because, like, to me, the way I see it is that it makes a lot of sense that they're coming for the operational world. And the synergy I see is that, one of the core, I guess, value pieces that Databricks and Snowflake offer is comprehensive governance. And it makes a lot of sense that you might want to use a database that has integrated governance with the analytics, right? Because stuff like PII or sensitive financial information, without it, very often developers in the operational plane need to solve these problems as well. And it costs time. So either they don't solve it and then get somebody angry and come there and force them to solve it, or they have a very diverse solutions across the whole plane, right? Because very often you have like tens of different teams building different stuff, and once this is a part of the platform, and then you might have a uniform solution provided by the platform that maybe you tag this piece that, yeah, this is PII, this needs to be encrypted in using this set of keys or something like that. This makes data management a bit easier. And something that I haven't said in public yet, but to me this is kind of foreshadowing these platforms introducing a Kafka-based streaming solution as well, because Kafka is a standard in the operational world or on the connection of it. And right now, both Snowflake and Databricks, they support Spark structured streaming. So this is micro batches, right? So and this is just not Kafka compliant, and because Kafka has a different protocol and different formats, a lot of things. So it might make a lot of sense if they are coming for the relational databases. It might make a lot of sense to come for the default streaming protocol that exists. That will just broaden their market. So I'm really curious to see if this will happen within the next year or so, where Kafka compliant streaming solution. Sorry,
yeah, that would make. Oh no, that makes perfect sense to me. As far as like what would be like sort of the next thing. So we'll see which Kafka startups they buy out next year. And then on that note, like, but I do think eventually, as far as like integrating governance and things like that, I do think that is a place where a lot of these Lakehouse catalog projects could eventually go. And then eventually build integrations with, like right now they're building all integrations with analytics tools to share governance. But I don't see a reason why not eventually, once you've sort of, these projects have matured on the analytics side and kind of cover analytics use cases, why they couldn't necessarily be something that builds an integration with like open source databases like Postgres. So that way, something like a Postgres could actually leverage a catalog. So that way you see all your tables across both environments in one place without having to log into massive clouds. Again, I do think it's a couple steps away, because right now I think those catalog projects are so, whether we're talking about Unity or Polaris, they're still so young. There's still a lot of analytics ground for them to cover. But I do think like the inevitable evolutions, you'll have this sort of central catalog that's just completely decoupled from everything else, that tracks everything and governs everything. But otherwise, I agree with everything you just said.
Yeah.
We are a little short on time, but like we had a couple of more questions, and we had questions from the people also on the LinkedIn. And should we take the questions now, or like what do you think?
Yeah, I can go longer. It's fine.
Okay. So I just have a quick question on specifically on the engines part. Like, so we discussed the cataloging part, we discussed the storage part. On the engine part, as you already mentioned in one of your responses, that there has been there has been some caching involved.
Mm-hmm.
And both the so I've been reading a lot of documentation around Dremio as well as Starburst with the Trino one, and they both say that they have the best price to performance ratio.
Yeah, I mean, here's the way I would put it. Like, if you're someone who's considering both of them, try them out. Like I especially if you're using version 26 of Dremio, and that's the problem. Like when you see the benchmarks on the sides, like which versions of both products do they use? Okay, like I've definitely seen some benchmarks on one side where they were using older versions of Dremio, and saying, "Oh, hey, we're faster," but that's not our current performance. But and it was like a 3-year-old version. But on that note, like again, use it. But now, as far as like what I can say as far as how Dremio achieves its performance, there's a couple of key differences. I do want to point out. One is our use of Apache Arrow. Like Apache Arrow, one of the co-creators of Apache Arrow is the founder of Dremio. And so Dremio has been using Apache Arrow from the beginning before really any other tool was using Apache Arrow. So we really optimized for using Apache Arrow. Again, we've always aimed to be sort of really early on a lot of these open source projects. So we have a huge performance boost, and then we have a Apache Arrow flight interface. So not only are we processing the data fast because it's Apache Arrow, and this is just a raw performance, but we can deliver the data fast. Like that's the other thing to keep in mind, where in other situations you may only have a JDBC, ODBC interface. So even if you're processing the data really fast, your ability to pull that data down in large quantities will hit a bottleneck in that JDBC, ODBC piece. But also, not only do we process the data fast, but because we do have like a lot of different performance layers, we optimize the queries. Which I don't have. Nowadays most places probably have a cost-based optimizer of some sort, where they're optimizing queries and optimizing their pushdowns and things like that. But when it comes to, we have the reflections that we talked about earlier, which is a very unique sort of mix of indexing and materialization, because you have the metadata as an index and you have the physical sort of Parquet files as a materialization, but the way it transparently. But when you're using Iceberg, the fact that we can autonomously manage that is a big differentiator because, hey, you don't have to think about it. And then 2, we do have a bunch of new caches. Again, all Iceberg based, because with Iceberg, it's much easier to cache when you can actually detect when the table's changed. So we have like a results cache, so that way you don't have to recalculate results on Iceberg tables that you've already done. We have a query plan cache, so you don't have to replan a query. We also have something called the columnar cloud cache, which works for not just Iceberg tables, but also Parquet data sets. And what that's doing is that it's caching not just the whole Parquet file. Sometimes if a certain query is only accessing certain row groups or certain columns in a row group, it'll just cache that. And basically that way you reduce the amount of round trips to S3 you're making. So that way you also reduce your egress costs. So there's a lot of different places where we are optimizing for performance. And we also have Iceberg clustering, which is something I think right now, well, S3 just announced their Iceberg clustering, but before, like last week, we were the only vendor that had Iceberg clustering as a service. But you could still do it yourself with using like Spark or whatnot. So that would be what I would say about sort of that topic. Like at the end of the day, like people can hear me talk about all the coolness. I love Dremio. I advocate for the top product because I do believe in it, and I do find it quite exciting, the technology. But at the end of the day, people just need to run queries on their data and see what works better for them. Because again, every tool is optimized in different ways. So what's optimized for your workflows, well, you'll only know when you run your workflows.
Definitely.
Thanks. I have a question from Stan. Hi, Stan. The question is, Alex, what have you seen is the most common way to ingest data into Lakehouse? How are Lakehouses initially created?
I mean, I think because of the level of ecosystem support over the last few years, a lot of the early Lakehouses were mostly Spark, just because like it's really a Spark or Flink, and you're using just the libraries for your relative data format. I think you have a lot more options now. So you're starting to see a lot more like Fivetran usage or Confluent usage or Red Panda usage, or there's so many of them, Estuary, like every ETL vendor now has Iceberg support. So I mean, that's just really happened over the last year. So I think as far as people shifting over to those services, it's still very early days. Like I would say like a lot of the big players built their Iceberg Lakehouses, but right now, I mean, as far as like the lower big to medium, they're just starting to architect their Lakehouses. And then as far as like the smaller data footprints, although I would advise, like if you're someone who's like right now still using your operational databases for analytics and we're considering doing a data warehouse, I do think that the barriers to entry are low enough now that you could just skip the data warehouse phase and go straight to a Lakehouse. The tools are there and the cost for them, like, and again, not, you know, just because this is what I know, like for example, like with Dremio, you could have a Lakehouse overnight, just with a few clicks, and you just be based on usage, and you have everything you need. It's all managed for you, and you don't necessarily, again, you're going to have a lower price point, and you won't have to worry about this again when you scale up. Because that's the thing, what happens, you move to a data warehouse, and then you're going to eventually scale up to where you need to move to a Lakehouse pattern. And that's where you're starting to see a lot of this conversation now.
Right.
So,
the question was going into detail about the streaming ingestion. How is the freshness of the data in the Lakehouse? You've mentioned more than once that it's like people care mostly about how fresh the data gets in there, right? So processing can be a bit slower, but you want to have access to fresh data every time.
Yeah.
So the question is, how does this look like in the field? Not about the best practices, but what do you see in the like global landscape?
I think I've seen people, you know, keep it within like seconds. So like Iceberg, I mean, for Iceberg streaming, keeping it with seconds, and then of course when you're using formats that really specialize in streaming, like a 𝗬𝗪 or a 𝗬Mon, you can kind of get pretty much the latency you want. There's other things you have to kind of figure out, but
so people are like ingesting, like creating new Iceberg snapshots in seconds and then cleaning them up afterwards. How does this work?
Yeah, it depends on sort of your SLAs as well. Like for example, like it also depends on how much data, how many events are coming in, things like that. So I mean, again, if you're talking about like thousands or hundreds of thousands of events, that might be trickier than, you know, if you or like a smaller amount of events, as far as how quickly you can update them and write them. But I have seen people hit low latencies. But again, I don't know the specific sort of amount of data throughput that's happening at those latencies to be able to sit there and say, okay, hey, because at a higher throughput, that's going to be more of a challenge than at a lower throughput. But it is possible. And then usually, again, depending on sort of how you're partitioning the data, like if you're partitioning it based on hour, you might be running a cleanup job every hour. So there might be sort of like choke points where depending on how you design it. But really, the way I wouldn't say like that's typical, and nor should that be what I would expect on the Lakehouse right away. Like right now, like I would still expect like maybe like a 5-second latency or something like that. And in most use cases, depending on throughput, depending on sort of what your budget is, depending on sort of what how you structure how the jobs are like structured, and because there's certain if you really optimize your write patterns for so that way it writes it to perfectly separated files, like the way it's partitioned and the way the data is sorted going in, you can optimize in all sorts of ways, but oftentimes you don't know what the data is going to look like coming in, so you can't optimize for those things. So can you hit things really, really tight things if everything kind of lines up perfectly? It's possible. I wouldn't bank on it.
But you really need to and how much it costs, right?
Yeah.
So what is pretty popular right now in the Kafka world is the abstraction of a table topic. Confluent has this table flow product, and first of all, you have a single schema for a Kafka topic and Iceberg. So you can have super fresh data, but also optimize the amount of Iceberg writes. And then Confluent supports, and this is in general natively supported in Flink, that you might run snapshot queries at a certain moment in time. I'll do the query on maybe the last 15 seconds of my stream, but also the last 15 years of my Iceberg, right? So you can get the analytical query performance on the large volume, but also query your stream at the same time. In a bit less optimized manner, but if this is just, let's say, 15 or 30 seconds, then it doesn't matter.
100%. And then if anyone wants to see a video, like I actually did a video with TableFlow, if anyone wants to see like TableFlow in action, where I actually ingest data from a stream in TableFlow and then open it up in Dremio, so you can see how you can see that data pretty much right away. It's actually a really cool feature. I really did, and it wasn't that hard to use at all. It was really cool.
Yeah. I was waiting for the public release for a while, but then when they did announce it, I was like, yeah, okay, can I get access? But yeah, I like it a lot, and other vendors are also providing very similar features. This abstraction is kind of, but the downside is that you actually need to use a processing engine that has access to both Kafka and Iceberg, right? You don't have this super fresh data in our Iceberg right away. This is kind of the design, the way it's supposed to work.
100%. You have to write the Parquet files and all that stuff, so you're limited by how fast you can write all that.
And these were all of the questions we had in the chat. Sachin, maybe you have something still you want.
I have many. I have many things. Maybe you could just take this, make this 2 hours. But yeah, maybe the last one, and then maybe we can just wind up with the next episode that we are following up. So as you already mentioned, that we have different use cases and different latency requirements, maybe for Iceberg, which is 5 seconds of ingestion requirement, and maybe use 𝗏𝗏 for even lower latency requirements of ingestion, right? Do you see these open table format coexist or can be used in a hybrid fashion for specific use cases or specific workload use this table format versus for the different one for this table format in that direction?
Yeah, I do think that we're moving towards a world where these formats can live in more harmony. I think everyone the last couple of years were trying to fight to be the standard. Now that fight has, I think, for the most part dissipated. Now, basically, instead, they can figure out how they can coexist and find their use case. So it's clear to me, like Paimon and 𝗏𝗏 are going to generally be, your very streaming focused formats. Delta Lake is going to be always your first class citizen on the Databricks platform. And then, Iceberg pretty much is your general all-round, wear of all hats. So I do think things like Xtable help. Now, generally, to me, like overall, like ideal world, you do want to write and read to the same format, because oftentimes, like the way the metadata is structured is optimized to the way that the data files are written. So, for example, in Iceberg, things like partition evolution and hidden partitioning only exist if you are writing to Iceberg in the first place. So if you're not writing to Iceberg, you can't use those features. So there are trade-offs to doing something like, let's say, hey, let me ingest on 𝗏𝗏 to get hit my latency requirements, and then using Xtable to translate the metadata into Iceberg. Again, it depends on what you need and what you don't need. But I just want to make sure that there is trade-offs, and oftentimes But I do think there are tools, and when you think of like, hey, uniform over there in Unity catalog, whatnot, and or even just having federation tools like a Dremio or a Trino that can query multiple formats. There's lots of different ways where these formats can coexist. We have a lot of customers that have Iceberg and Delta Lake. They coexist depending on sort of, they'll have Iceberg tables in Snowflake, and they have Delta tables in Databricks, and then they'll connect their Unity catalog to Dremio. They'll connect their Snowflake to Dremio, and then query and join all the tables right there from Dremio and deliver to their dashboard or whatnot. So there's a way for all these tools to coexist. And then whenever you feel like you do have too many different data sources and you're not sure how they should all connect, I'm definitely a person you can reach out to, because that's definitely where we specialize here over at Dremio.
For sure. Where can we find you?
Everywhere, but linkedin.com. But you can find all my links to all my social media, my blogs, everything over there at alexmerced.com. And then go to dremio.com to learn more about Dremio. But if you go to alexmerced.com, you'll be found to find the link so you can download the Iceberg book, links to my social media, to the blogs. And then dremio.com, you can find information about how you can try out Dremio for free. That's basically where you can find more information on me.
Awesome.
Yep. Thank you so much for giving us your time on your birthday. So people who are still live, like more than an hour session with us, please wish Alex a happy birthday and maybe send some gifts to his place.
Oh, thank you.
Yeah. But yeah, so this was great talking to you. We have learned a lot. I have created a lot of notes. Maybe we'll try to do something similar session in few months or something like that, depending on your availability. Going forward, we'd have more depth discussion. So I'll just move the banner just to show what is going to follow next. 1 second. So in our next episode, so this is the link, like as we were discussing, like you can follow us on LinkedIn. This Alex link is also there, but Alex has already mentioned that you can go to the alex.com, and from there you can find the other relevant links. The next episode that we are planning is on the Lakehouse architecture and analytical plane. We have this the Lakehouse superstar with us today to discuss those things in detail. But the next session will be a more structured in terms of we'll have slides presentation the same way that we had previously for the first two sessions, and we maybe will walk you through those in more depth. So this if this spiked your interest in Lakehouse and you want to try it out, be joined with us in the next episode as well. And then these are the like YouTube and LinkedIn where you can find our older recordings of episodes.
Yeah, thank you very much, Alex. Thank you, Sachin, and to anyone watching as well. It was a great pleasure.
Yes, it was a lot of fun. Thank you guys so much. I look forward to seeing you guys again.
Bye.
Bye.